Okay, so we're going to look at these questions that I gave you in class today, this revision sheet, which should prepare you very well for the test tomorrow on Algebra 2. So let's go straight into them. In the expansion of 2x plus 1 times x squared plus px plus 4, where p is an element of n. Now, I'm just going to stop there. In the expansion of. So therefore, you have no choice but to multiply those two brackets together. So let's do it. 2 by x squared is 2x cubed. 2x by px is 2px squared. 2x by 4, 8x. Then x squared, then px, then 4. Okay, now read on, because you've expanded it, okay? The coefficient of x, if you don't know what a coefficient is, you can't go any further. The coefficient is the term that stands in front of a variable. So for example, minus 4x squared, minus 4 would be the variable of x squared, etc. So the coefficient of x is twice the coefficient of x squared. Now, what I have to do here is realize that x squared and x are all in those four terms. So I'm just going to rewrite this with the terms that have the same x together. So 2px squared, and then plus 1x squared plus 8x plus px plus 4. So there is your x squared and there is your x. Now if we remember anything from chapter 1, when you have two terms that have the same common term, then you take it out as a common factor. So plus 2p plus 1 x squared. This one has x in common, so 8 plus p x plus 4. And straight away now you see what the coefficient of x squared is and the coefficient of x. But here's what we're told, that the coefficient of x, this one here, is twice the coefficient of x squared. The coefficient of x, which is 8 plus p, is twice the coefficient of x squared. See, so you just do what the question tells you to do. So 2p plus 1 is the coefficient of x squared, 8 plus p is the coefficient of x, and the coefficient of x is twice the coefficient of x squared. And now you've got an equation in one variable. So 8 plus p is equal to 4p plus 2. Just bring it up here. You get 8 plus p is equal to 4p plus 2. Just write it again. Now, let's work this out. We get 3p is equal to 6. So p is equal to 2. Just by a small amount of manipulation, p is equal to 2. Okay. Solve the equation. Now notice straight away there are factors. Okay. So one of the quickest way, as we already know, to get rid of factors is to multiply across by the denominator. But there are 3 of them. So what I would suggest you do here is you get a common denominator, which is made up of all 3 denominators multiplied as a product. And then you adjust each of the numerators to reflect that new denominator. So 3 was over 2x plus 1. So therefore 2x plus 1 has been multiplied by 5 and 3x minus 1. So I suppose the easiest way to say it would be that you multiply the 3 by the other 2 denominators. See that? So 3 by 5 by 3x minus 1. Put down your plus 2. 2 is over 5, so that means you multiply 2 by the other 2. 2x plus 1 and 3x minus 1. And then you write down equals 2. And because 2 is over 3x minus 1, well then 2 will be multiplied by these 2. 2x plus 1 and 5. Now notice, my equal sign is in my numerator. So therefore my equation that's going to give me the solutions is in my numerator. So I don't have to worry about the denominator anymore. The denominator just helps me to work out what the new numerator is going to be. And the easiest way to do it is this. If 3 is over 2x plus 1, then 3 gets multiplied by both the 5 and the 3x minus 1, etc. Okay, so just keep that in mind. Just take those off. Okay. So let's work with the top line. 15 times 3, that's 45x. 15 minus 1 minus 15. Plus 2 times. I'm going to multiply these two brackets together using the FOIL method. So that gives me 6x squared. Then minus 2x plus 3x, which is plus x. And plus 1 by minus 1 is minus 1. And that is equal to 2 times 10x plus 5. And the last thing then, take away the remaining brackets. 45x minus 15 plus 12x squared plus 2x minus 2 is equal to 20x plus 10. Now gather it up and make your quadratic equation an x squared. So 12x squared, that's the first term. No other x squareds there, no. X is next. So you've got 45 and 2 is 47. And 47 minus 20 is plus 27. X. So that's your x is taken care of. And then you've got your minus 15 minus 2, which is minus 17. And minus 17 minus 10 is minus 27. And that's equal to 0. Now, look at the numbers in your quadratic, 12, 27 and 27, all divisible by 3. So you divide that by 3, so you can get it simplified, down to 4x squared plus 9x minus 9 is equal to 0. And at this stage, totally up to yourself. If you want to do it by inspection, you just open brackets. Or if you want to go to minus b formula, that's fine, because you're told to solve. So you may go straight to minus b if you wish. 4x and 9, let me see if I can work this out. 2 3s are 6 and 2 3s 6 is 9, 4 3s is 12. Yeah, so 4x and x, and then you have 3 and 3. And the way to test that is you multiply the two outside terms. 4x by 3 is 12x, and 3 by x is 3x. 12x minus 3x will give you the required plus 9 in the middle. So straight away, 4x minus 3 equals 0, or x plus 3. So you just set the factors equal to 0, and then you solve. X is equal to 3 over 4, or x is equal to minus 3. That's it. Okay, so there's your two answers for x. Okay, next one. Solve the simultaneous equations. I know you love these because they're a real set piece, and you know they are doable once you take your time. Tiny steps in the beginning will make big trouble for you as you go along. So let's work this out. Let's see what we'll do here. I suppose we might as well try and get rid of the z's from the first two, really. And I suppose you can do the same the second one. It's going to make it quite straightforward. Okay, so that means we're going to multiply the top line here. Equation number 1, we're going to multiply by 2 in order to get rid of the minus 2z and the plus 2z. So that's going to give me 4x plus 6y minus 2z is equal to minus 8. Okay, so I'm multiplying that by 2. And then let's keep equation 2 as it is. Okay, so straight away the z's are gone, and you get 7x plus 8y is equal to 14 minus 8, which is 6. Okay, and then you can take equation 2, oh, it's actually 1 and 3 if you want to. Yeah, easily, 1 and 3. So we've got 2x plus 3y minus z is equal to minus 4. Now, I want to get the z's to match, so I'm going to multiply actually this one by minus 3. So that's going to give me minus 6. That's going to give me minus 9y. That's going to give me plus 3z. And that's going to give me equals 12. So the equation here is going to be minus 6x minus 9y plus 3z is equal to 12. Okay, that's just in order to get these ones the same. Then put down the x minus 3z is equal to minus 13. And again, you'll notice your z's are gone, and you'll end up with minus 5x minus 9y is equal to 12 minus 13, which is minus 1. And there's your second equation in x and y. So we're now going to take these two equations here, and we're going to set them down as a pair of simultaneous equations. 7x plus 8y is equal to 6, minus 5x minus 9y is equal to minus 1. Well, look, we don't really have much of a choice here, do we? The x's and the y's are quite difficult to cancel, but they're already opposed, both of them, so I'm just going to get rid of the x's. I'm going to multiply that by 5, so it'll give me 35, and this one here by 7, so it'll give me minus 35. So that's going to give me 35x plus 40y is equal to 5 6s, 30. Multiply the bottom line by 7, gives you minus 35x. 7 6 what are we? 7 9s are 63 minus 63y, and that's equal to 7. That's minus 7. So your x's are gone, and now you end up with minus 23y is equal to 23. So y is minus 1. So there's y. And then making your way back, let's go to this equation here and put in minus 1 for y. Minus 5x minus 9 times minus 1 equals minus 1. That gives me minus 5x plus 9 which is equal to minus 10. So therefore x is equal to 2. And then you take both of those back to one of the original equations up here. And look, let's use this one. That's very easy because we know what x is. So I'm going to take x all the way back up to the third equation, which tells me that 2 minus 3z is equal to minus 13. So minus 3z is equal to minus 15. So z is equal to 5. And there's your x, y, and z. Okay, and again, pure practice with these things. If f of x is equal to x cubed minus 17x squared plus 80x minus 64, show that f of 1 is equal to 0. Now, numbers in brackets are roots. So straight away, they're telling me that the root is equal to 1. And you know what you do with roots? Roots substitute. So you're going to put 1 into this one, which becomes 1 cubed minus 17 times 1 squared plus 80 times 1 minus 64. Now, show that f of 1 equal to 0. In other words, show that 1 as a root turns the function to 0. So if I do this thing correctly, this should go to 0. 1 minus 17 plus 80 minus 64. Well, minus 64 and minus 17, that's minus 81, plus 1 is minus 80, plus 80 indeed is 0. They all cancel. Minus 64, minus 81, minus 80, plus 80 cancels. Okay, so I've done the first part. And it says, find another value of x for which f of x is equal to 0. There's a bit of a cheat, okay? If you want to find out values of x that satisfy the equation, the values of x that satisfy this cubic equation are always factors of the last term. Okay, so that means it could be 1, it could be 2, it could be 4, it could be so on and so forth. Now, that's a lot of them, all right? Easier way. If you take the root is equal to 1, what does that mean? That means you have a factor, x minus 1. And now we know that if I multiply x minus 1, which is linear, by a quadratic, I will get x cubed minus 17x squared plus 80x minus 64. I think this is the easiest way to do them. So, x multiplied by what gives you x cubed? Well, that's x squared. Minus 1 multiplied by what gives you minus 64? Well, that's plus 64. And then we have an ax in here that we wish to solve. Multiply out the left-hand side. Get all these terms together. That gives me x cubed plus ax squared plus 64x minus x squared minus ax minus 64 equals x cubed minus 17x plus 80x minus 64. And as I told you before, the first terms don't tell you very much, the last term doesn't tell you very much, so the remaining terms must be grouped left and right according to the x's that they belong to. So for example, you get ax squared minus x squared is equal to 17x squared minus 17x squared. That should be a square there. Okay, and you get a second equation. You get 64x minus ax is equal to 80x. Okay, let's drop the x squared from all of these. And we get a minus 1 equals minus 17. So therefore a equals minus 16. Let's just see if it gives the same one here. So we end up getting 64x minus ax. So that's 64. Get rid of the x's because they're all the same. So you get minus a is equal to 80 minus 64. So minus a is equal to 16. So a must be minus 16. Gives the same answer. So you put that back into your quadratic up here. So you take your a equals minus 16. You bring it back up into this quadratic here. And that's going to give you x squared minus 16x plus 64. And then all you've got to do is open the brackets. X and x. 8. 8s are 64 and 8 and 8 is 16. Minus, which means that x is equal to 8. And again, I told you earlier on that if you go to the last number in any cubic expression, the factors of 64, some of them will be roots. So 1, 2, 4, 8, etc. You just keep going up in terms of the factors of 64, and one of those is going to be another root. The difficulty is you got to substitute them all in, and it takes a while to find it. Much easier if you follow the method that I showed you about comparing coefficients, as I've done there, and you get a value of 8. And it just asks one more value, isn't it? Yeah, find another value of x. Okay. The function f is such that f of x equals 2x cubed plus 5x squared minus 4x minus 3. Show that x equals minus 3 is a root. X equals minus 3 is a root. which means, if you remember the factor theorem, that if x equals minus 3 is a root, then x plus 3 is a factor of what? Is a factor of 2x cubed plus 5x squared minus 4x minus 3. So we're going to do exactly the same thing again. If you have a linear factor, the remaining factor is quadratic. So x plus 3 multiplied by a quadratic will give me the 2x cubed plus 5x squared minus 4x minus 3. And again, we do the same thing we've always done before. Let's try and work out what this quadratic is. X multiplied by what gives me 2x cubed? That's 2x squared. And 3 multiplied by what gives me minus 3? That's minus 1. And then we have an ax at the center. Multiply out your left-hand side. 2x cubed plus ax squared minus x plus 6x squared plus 3ax minus 3 equals 2x cubed plus 5x squared minus 4x minus 3. So the 2x cubes tell me nothing, the minus 3 tells me nothing, so that means the x squareds and the x, that's where you're going to get your answer from. So let's take the x squareds. Ax squared plus 6x squared equals 5x squared. And because they all have x squareds, you can ignore the x squared and you get a plus 6 equals 5. A must be minus 1. Okay, and this is going to give you the same thing. If you were to use the x's, you get exactly the same thing. It doesn't matter whether you use the x squareds or the x's, they'll give you the same value for a. A is equal to minus 1, which means now I bring it back up here to this quadratic, and that's going to give me 2x squared minus x minus 1. And then you open your brackets, like so. 2x squared is 2x by x. 1 has to be 1 by 1. And I want minus x. So do the outside ones, that's 2x and that's 1x. So minus 2 plus 1 is what we're looking for. So 2x equals minus 1, x equals 1. And here x equals minus a half. So there's the second one. Now what did it say? Find the other two roots. There they are. The roots are the solutions to the factors that have been set equal to 0. Solve the simultaneous equations here. One is a quadratic, the other one is a linear. Okay, so in this case, there's a set procedure again. You take the linear equation and you work out what x or y is in terms of the other variable. So therefore, I get 2x is equal to minus 1 minus 3y. So therefore, x is equal to minus 1 over 2 minus 3 over 2y. Okay, and what I'm going to do now, once I've discovered what x is, I'm going to take that new version of x and substitute it into the quadratic. So I'm going to end up getting minus a half minus 3 over 2y to be squared plus minus a half minus 3 over 2y multiplied by y plus 2 times minus a half minus 3 over 2y to be squared. Now take your time, okay? Just take your time with these things. Oh, sorry, y, isn't it y? It's only x. My apologies. My apologies. My apologies. Take that out. That's stupid. Somebody put in for x. So, what's the last part? Sorry, 2y squared. So, 2y squared, that just stays the same because it's only x we're putting in for. So we're putting x in here and here, and we're leaving the y's alone. Okay. Now, square the first one. You're squaring a binomial, so you square the first number, a quarter. You square the last number, 9 over 4y squared. Then you multiply these two together, which gives you 3 quarters, and then you double the result, so you get 6 quarters. Do it again. Square the first. Square minus a half, you get a quarter. Square minus 3 over 2y, you get 9 over 4y. Multiply these two together, and you get 3 over 4. Double the result is 6 over 4. So therefore you get a quarter. Plus 6 over 4y, plus 9 over 4y squared. Next one, minus a half y, minus 3 over 2y squared, plus 2y squared. And that's equal to 4. Okay, that's what the equation says. Now, we've got to get rid of these fractions, so I'm going to multiply everything across by 4. Okay, let me just change the colour there, and I'll show you what I'm going to do with 4. Okay, so I'm going to multiply that by 4. This gets multiplied by 4. That gets multiplied by 4. 4, 4, and 4. So 4 cancels there. That 4 cancels with that one. That 4 cancels with this one. 2 goes into 2. 1 goes into 4 twice. 2 goes into 4 twice. And that's it. Okay, now, and that gets, of course, multiplied by 2 over here as well. So we end up with 1 plus 6y plus 9y squared. And then we have minus 2y minus 6y squared plus 8y squared is equal to, what was I multiplying across? By 4. So by 4. 4 4 is 16. Okay, tidied up. 9y squared minus 6y squared is 3y squared. 6y minus 2y is 4y. Is that it? 6y minus 2 is 4. 6 minus 2, yeah, plus 4y. Actually, I forgot something there, didn't I? Back again. Let's try that again. 9y squared minus 6y squared is 3, plus 8 is 11y squared. That's better. Okay, now the y's. 6y minus 2y is 4y. And then you have 1. That's all on that side, isn't it? 1, and then equals 16. So 1 minus 16 is minus 15. That's equal to 0. Okay, so let me try that again. 9 minus 6y squared is 3y squared. 3y squared and 8y squared is 11y squared. And then you have 6 minus 2 is 4y. And then the numbers are 1 and 16 over here. So get that 16 back over as minus 16. 1 minus 16 is minus 15. Okay. Now let's see. So 11y and y. And I want 4 as a difference. So you could have 1 times 15. See that? So do the outsides. 11y by 1 is 11y. 15 by y is 15y. And there's a difference of 4 between them. And I want a difference of plus 4. So plus and minus. Giving me an answer of y is equal to minus 15 over 11. Not nice, but you've got to deal with them. And the second one is y equals 1. Okay, what are the corresponding x's? Now, all you've got to do there is go back to this equation, this one, yeah? And take the y in and put it in here. So you end up with minus a half minus 3 over 2 times minus 15 over 11. Let's do the first x. So that x there will become minus a half. Minus 3 over 2 by minus 15 is plus 45 over 22. So we get a minus 11 over 22, so it's a half, plus 45 over 22, which will give me 34 over 22, or 17 over 11. So the first value is x, y here, is equal to minus 15 over 11, and the corresponding x value is equal to, let me just bring it up a little bit, is equal to 17 over 11. And here, y is equal to 1. Now that's easy. Just bring the 1 back up to this equation here again, and you put 1 in there. So it becomes minus a half minus 3 over 2, minus a half minus 3 over 2, and that will become minus 4 over 2, which is x equals minus 2. That's it. So you take this 1, see that? There's your y values, and x value. There's the first pair, and there's the second pair. That's it. Okay, the y equals 1. Bring it up here to this equation. It becomes minus a half minus 3 over 2. Yeah, so minus 1 over 2 minus 3 over 2 is minus 4 over 2, and that simply becomes minus 2. That's where I get the corresponding x value from there. Question 5, interesting question. First of all, you notice it's a right angle triangle. See that? So therefore, the theorem of Pythagoras is what we look at, which tells me the hypotenuse squared is equal to the sum of the squares on the other two sides. So straight away, who's the hypotenuse? The hypotenuse is the side always opposite the right angle. So that's the hypotenuse. And then the other two sides are just called A and B in any order. A and B. So the theorem of Pythagoras says h squared is equal to a squared plus b squared. So that means 5x minus 9 to be squared, that's the hypotenuse squared, is equal to x minus 1 to be squared plus 4x to be squared. Now don't forget your FOIL method over here. 5x to be squared is 25x squared. Minus 9 squared is plus 81. Multiply the two together. That's going to give you minus 45x, and double the result, minus 90x. And that's equal to, again, binomial, x squared plus 1 minus 2x. And finally here, be careful, because both of the numbers in the brackets have to be squared. So the 4x squared becomes 16x squared. So again, we're going to get a quadratic here. And quadratics, as you can see in this chapter, are very, very popular. Okay, let's see what we have. 16x and x squared, that's 17x. So 17x, 25 minus 17 is... 25 minus 17, God, it's too late for me. Minus 17. 25 minus 17 is 8, as I expected. I didn't want to take a chance. 8x squared. So 25 minus x minus 16. Then you have minus 90 plus 2, which becomes minus 88x. And then you have 81 minus 1, which is plus 80, is equal to 0. All divisible by 8, which makes it a nicer quadratic to deal with. X squared minus 11x plus 10. And all you've got to do then is open your brackets. X squared is x by x, or you can go to your minus b. If you're told to solve with a quadratic, go to minus b if you wish, doesn't matter. I want factors of 10 to add to 11, that's 10 and 1. And I want them to add to minus 11, so minus 10 and minus 1, which tells me straight away that x is equal to 10, or that x is equal to 1. Now, let's be careful. Do both answers work? So let me take x equals 1, and let's see what happens. If I put 1 back up here, yeah, 5 ones is 5 minus 9 is minus 4. How can a line be minus 4 units in length? It can't. So x equals 1 is not going to be an answer, so we reject it in favour of x equals 10. 10 fives is 50 minus 9, that's 41. That works. Okay, so you've got to be very careful that if you get two answers, particularly in a question dealing with measurement, just check the two answers and see do both of them actually validate what we were saying earlier on. Look, take the x equals 1, put it in here into a, put it here. That gives me 1 minus 1, which is 0. So it's just telling me a has no length? Can't be. So therefore the answer in this case, x is equal to 10. Solve the equation x cubed minus 3x squared minus 9x plus 11 equals 0. Now, no starting point whatsoever. But that's okay. We just look at the last term. And the last term tells me that 11 is just 11 times 1. So one of these has to be the first root. So let's test 1 and see what happens. Test x equals 1 as a root. And let's put it in here. 1 cubed minus 3 times 1 squared minus 9 times 1 plus 11 equals 0. 1 minus 3 minus 9 plus 11 is equal to 0. 11 and 1 is 12, minus 9 is 3, minus 3 is 0. That's correct. So I found it. So x equals 1 is a root, which means that x minus 1 is a factor. Now, they want me to get the solution of this thing using the answer as a plus b root c. There's only one way to get a Searle answer to a solution, and that is to use the minus b formula. So the first thing I've got to do is try and figure out, well, if x minus 1 is a root, what quadratic do I multiply it by to get x cubed minus 3x squared minus 9x plus 11? X by what will give me x cubed? Well, that's x squared. Minus 1 multiplied by what will give me plus 11? The answer is minus 11. So therefore we have our ax in the middle. Let's multiply out this side. We end up getting x cubed plus ax squared minus 11x. Then minus 1x squared minus ax plus 11. And that's equal to x cubed minus 3x squared minus 9x plus 11. And again, first terms tell me nothing, last term tells me nothing, so the solutions are going to come from the remaining terms. So let's take the x squareds. Ax squared minus 1x squared is minus 3x squared. So ax squared minus 1x squared equals minus 3x squared. Cancel the x squareds because they're common to everything. A minus 1 equals minus 3. A must be minus 2. Okay, so bring it back to the quadratic we're looking for. This one here. So bring that back all the way to this quadratic. Shove it in for A. and you get x squared minus 2x minus 11 is equal to 0. And then you have to use the minus b formula. No way around it. So a is 1, b is minus 2, c is minus 11. And we're going to put them into the minus b formula. Minus b plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2 times a, which is 2 times 1. Oops, 2 times 1, because a is a value of 1. So 2 times 1. Okay, 2 plus or minus the square root of. Now, 4 minus 4 times minus 11 is 44. 4 and 44 is 48. All over 2 ones, which is 2. So that's going to give me 2 answers. 2 plus, now root 48, 16 goes in there 3 times. So root 16 by root 3 is 4 root 3. If you don't believe me, just stick root 48 into your calculator and it comes up as 4 root 3 all over 2, or 2 minus 4 root 3 all over 2. So therefore the answers will be, and again if you notice, look at this one here, look at that, everything in there is divisible by 2. So the first answer is 1 plus 2 root 3, and the second answer is 1 minus 2 root 3. And they are your 2 answers. Now what did they ask me in the beginning? Oh, write any irrational solution in the form of a plus b root c. So in other words, a plus b, that one. There it is. Okay. Sketch a graph of the following polynomial. Ah, okay. So sketch a graph of the following polynomial. All we need is our x-axis, like so. And I want to work out what the roots are. So the first one is x equals 0. The second one is x equals minus 3. The third one is x equals 2. The fourth one is x equals 2. And the last one is x equals minus 4. So we've got minus 4, minus 3. We have 0. We have 2, isn't it? That's it. 0 and 2. Yeah. So let's put 2 there. Okay. So they happen to be my roots. That's where the graph interacts with the x-axis. Okay, it passes through 0, it passes through minus 3, it turns on 2. Now that's key. So there's going to be a turning point there, and then minus 4 is going to pass through as well. So the way in which we find out what the arms do is by just multiplying out the x's. Minus x by x is minus x squared. Minus x squared by x squared is minus x to the 4. And minus x to the 4 by x is minus x to the 5. Okay? Now, if you can remember, always start with your right arm. If it's negative, the right arm is down. Okay? If the power is odd, this arm is up. And all we've got to do then is to do what the graph tells me. So go through 4, go through 3, like that, go through 0, and then turn on 2, and there's your graph. Okay, now just be careful and make sure you understand exactly what that is. Always write down the roots first of all. So there's your roots, because that is where this polynomial is going to interact with your x-axis. So make sure you turn all your factors into roots. That's 0, that's minus 3, that's plus 2 twice, and this one here is minus 4. So find out where they are. Then remember that if one root is present twice, that's going to be a turning point. And the last thing you do is you just, that's a TP, turning point, and then you just multiply your x's. So minus x by x is minus x squared. Minus x squared by x squared is minus x to the 4. And minus x to the 4 by x is minus x to the 5. And that tells me everything about the arms. If the leading coefficient is negative, right arm down. If the power is odd, left arm up. And all you've got to do then is go through 4, go through 3, go through 0, turn on 2, and that's what your polynomial should look like. Okay, solve the equation. X equals root x plus 6. Now, the key thing here is this side has a square root. And the quickest way to get rid of a square root is to square. But you've got to square both sides again because of the fact that it is in balance. X equals root x plus 6, so therefore it's balanced. So if I square the square root on the x plus 6 side, I'm going to have to square the x on the other side to keep the whole thing balanced. So that's going to give me x squared equals, and when you square the right hand side, the root sign just disappears, x plus 6. That's going to give me a quadratic, and then you can open your brackets like so, or you can go, because it's solved, you can go to your minus b formula if you wish, x and x, 3 and 2, and I want minus 3 and plus 2. X equals minus 2 and x equals plus 3. There's your two answers. Okay. Okay, another one of these. Solve the simultaneous equation. So here we go again. Now, this time look at the x's. The x's are all primed to set. The only thing I've got to do is change signs. So I'm going to take equation 1 and 2, and I'm going to change equation 2 and multiply it by minus 1. So that's going to give me 2x plus 8y minus 3z is equal to minus 1. Now I'll multiply equation 2 by minus 1. Minus 2x plus 3y minus 2z equals minus 2. The x's are gone. 8 and 3 is 11y. Minus 3 minus 2 is minus 5z. And that's equal to minus 1 minus 2 minus 3. So there's the first equation in two variables. Now I'm going to take equation 2 and 3. And again I'm going to multiply, well, I suppose let's just multiply the top one, equation 2 by minus 1 again. So we're going to get minus 2x plus 3y minus 2z equals minus 2. And just write out the third equation as it is. 2x plus y plus z equals 5. X's go again. 3 and 1, that's 4y. Minus 2 plus 1 is minus 1z. And that is equal to minus 2 and 5, which is 3. And there's your second equation in y and in z. Now bring both of those together. So you have 11y minus 5z is equal to minus 3. 4y minus 1z is equal to 3. So what I'm going to do here is I'm going to multiply the bottom line by by minus 5. And that's going to give me 11y minus 5z equals minus 3. Now multiply the bottom line by minus 5. So minus 20y plus 5z is equal to minus 15. And now your z's are gone. And you have minus 20 plus 11, which is minus 9y. And that's equal to minus 3 minus 15, which is minus 18. So y is 2. Lovely. No nasty fractions. Now let's work out what z is. So let's bring it back up here and stick y in. So we get 4 times 2 minus z is equal to 3. So minus z is equal to 3 minus 8, which is minus 5. So z is equal to 5. There's z. And then go all the way back to whichever equation you want at the very, very beginning. I'm going to take this one here and put in y and z. So you end up with 2x plus y, which is plus 2, z, which is plus 5, and that's equal to 5. So those 5s will cancel. So that will give me 2x plus 2 is equal to 0. 2x equals minus 2. So x must be minus 1. And there's your third value, x, y, and z. Oh dear, another one. Okay, let's keep going. Fractions, no. That means we're going to have to multiply that by 2 and this by 2. So x plus y plus z equals 16. We're going to keep that. Multiply across by 2. That gets rid of the 2. That's 5x plus 2y plus 20z is equal to 80, because you multiply everything across by 2. And this one the same. 4x plus y plus 8z is equal to 42. Ooh, okay. See the ones that are set up for easy cancel? The y's. You've got a plus y, a plus 2y, and a plus y. So that's what I'm going to focus on. Let me take equation 1 and equation 2, and I'm going to multiply the top equation by minus 2 so I can get the y's to cancel. Minus 2x minus 2y minus 2z is equal to minus 32. Then take equation 2. 5x plus 2y plus 20z is equal to 80. Okay, the y's are gone. 3x, and then we have plus 18z is equal to 80 minus 30 would be 50. That's 48. So there's equation 1 in two variables. Okay, now I'm also going to take equation, let's take equation 1 and equation 3. And all I'm going to do is x plus y plus z equals 16. And I'm going to multiply the bottom line by minus 1. Minus 4x minus y minus 8z equals minus 42. The y's are gone again. Minus 3x minus 7z is equal to minus 42. So 16 minus 42. Try that again. 16 minus 42, and that's minus 26. And there's the second one. Okay, so now look at the x's. They're all primed, ready to go. 3x plus 18z equals 48. Minus 3x minus 7z equals minus 26. They cancel. What do you end up with? 18 minus 7 is 11z is equal to 48 minus 26, which is 22. Lovely. So z equals 2. Go back up here and let's try and find out what x is. So we're going to put 2 in for z. Minus 3x minus 7 times 2 equals minus 26. Minus 3x minus 14 is equal to minus 26. Minus 3x is equal to minus 26 plus 14, which is minus 12. X equals 4. And finally, take both of these back to the easiest of the three equations, which is the top one, this one here. So take your z and your x back up here, and you're going to get the following. 4 plus y plus 2 equals 16. Y is equal to, has to be 10, because 4 and 2 is 6, y has to be 10. And there's your x, y, and z. Okay, another linear and quadratic. So again, the same thing as we said before. Take the linear equation and rearrange it until you get a on its own or b on its own. Now, if you notice, a is already reduced to a coefficient of 1. So therefore, I would much prefer here to get a equals 1 minus 2b. That's going to make life very, very easy. So a equals minus 1, I should say. Sorry, bringing both of these over here. So a equals minus 1 minus 2b, which then goes in here for a. So it goes in there and it goes in here. And that's going to give me minus 1 minus 2b to be squared minus 1 minus 2b times b plus b squared is equal to 3. And all of a sudden, you end up with a quadratic equation in b. So again, use your binomial. Square the first one, 1. Square the last one, plus 4b squared. Multiply the two of these together to get 2b. Double the result, 4b. Okay. Over here, we end up getting minus by minus 1 is plus 1. Plus 1 times b is plus 1b. Minus by minus is plus 2b by b is plus 2b squared. And then plus b squared equals 3. So what have we got? 4b squared and 2b squared, that's 6, and 1 is 7b squared. Then the b's, 4 and 1 is 5b. And then 1, and then you've got 3, bring it over here, that's minus 2 is equal to 0. Okay, let's see if I can work this out. 7 and 1, and then we have 2 and 1. And I want to get plus 5, so that must be plus 7 minus 2. And again, if you don't want to do that, go to minus b. As long as you can solve, you can go to minus b when you've got a quadratic equation. X equals 2 over 7, or x is equal to minus 1. Now, we've got to get corresponding values for y. So therefore, we go back up here and figure out, well, what is y? Oh, sorry, that's x. What am I dealing with? It's b, isn't it? Oh dear. That's b. That's b. That's b. And that's b. Okay, let's put them in, because it's an equation in b. So 7b and b. So b and b. b is equal to 2 over 7. And b is equal to minus 1. Okay, let's work out the corresponding value of a. Now look, see up here? I have an equation that tells me how to find a. So let's take up b, which is 2 over 7. That means a equals minus 1 minus 2 times 2 over 7, which is minus 1 minus 4 over 7, which is going to give me 7, 8, 9, 10, 11. Minus 11 over 7. And then for b equals minus 1, again go back up to this equation here. A equals minus 1 minus 2 times minus 1, which is going to give me a equals minus 1 plus 2, a equals 1. And there's your two values of a and b. Okay, here we go into your manipulations. Now we're nearly done. Write d in terms of c and d. So write d means you have to get d on its own. Okay, and the first thing I notice is d is in two different places. And I'm dealing with a fraction which I don't want to work with. So the first thing I'm going to do is multiply both sides of this equation. So e equals 2c minus d over d plus 1. So if I want to get rid of this, I'm going to multiply both sides by d plus 1. So d plus 1 there, and d plus 1 here, and they'll cancel, which will leave you with e times d plus 1 is equal to 2c minus d. Now, brackets are a thing in algebra that have to be done. So that gives me de plus e is equal to 2c minus d. And because d is my interesting term and it's in two places, get it to the same side of the equation. de, bring that minus d over here, plus d is equal to 2c, and get that plus e over the other side. Take out d as a common factor. And then finally, because e plus 1 is multiplying d, it will divide on the other side, 2c minus e over e plus 1. And there's d. And finally, obtain t. So you want to get t on its own. Now you'll notice straight away again, t is in two different places. But not only is it in two different places, it's stuck in a fraction, which I hate, but it's also underneath the square root. So the first thing I'm going to do here is I'm going to square both sides. And that's going to give me e squared is equal to, and when you square the right hand side, the square root just disappears. So it becomes t minus k over, and I'm going to multiply this bracket out, k plus k squared t. Don't leave brackets unworked, particularly when you're doing manipulations. Brackets tell you work has to be done, so do the work that it asks you to do. What do we ask for? T. Okay, so again, fractions, don't like fractions, so I'm going to multiply both sides by k plus k squared t, and that's going to give me that. So that's that side done, and then this one, k plus k squared t, that will cancel with that, and it leaves you with e squared multiplied by k plus k squared t is equal to t minus k. Again, do what the brackets tell you to do. E squared k plus e squared k squared t is equal to t minus k. And all you've got to do then is get the t terms on the same side. So I'm going to bring that minus k over to the left hand side. E squared k plus k is equal to t minus e squared k squared t. And now you'll notice on the right hand side, t is a common factor. So take it out. And that's equal to e squared k plus k. And finally, because t is being multiplied by 1 minus e squared k squared, that 1 minus e squared k squared will divide on the other side to give you e squared k plus k over 1 minus e squared k squared is equal to t. That would be a particularly difficult one, but it's still something you should be able to tease out in terms of getting rid of symbols, like the root sign, so you square both sides, clearing your fractions, gathering the letter of interest to the same side of the equation, extracting it as a common factor, and then whatever the common factor is multiplied by will end up dividing on the opposite side of the equation. Okay, so that particular set of questions will kind of give you an idea of what the structure of tomorrow's paper is going to be. If anything arises from that, or if there's any questions that you need to ask me in any one of those that I've just done there, please don't hesitate to send me an email.